business examples. So the quintessential example in business has to do with these three quantities called revenue, cost, and profit. Now, a company's revenue is all the money that they bring in. For example, if you, a human being, are considering yourself as a company, your revenue would be all the money that you bring home from whatever job that you have. Cost, on the other hand, is the sum total of all of your expenses. All the money that goes out. If you're considering yourself, the human being, your cost might involve the total of your expenses for your apartment, your expenses for your house, your expenses for your car, your expenses for your phone, for your insurances, etc. Internet, electricity, water, sewer, all of that. Those would be your costs. Profit, on the other hand, is a measure of the difference between your revenue and your cost. Profit is revenue minus cost. Now, profit is a quantity that can be either positive or negative, depending on whether your company is gaining money over time or losing money over time. Consider yourself the human being. Suppose, unfortunately, that you are one of the people who might have lost your job at the beginning of the pandemic. At that point, your revenue may have temporarily decreased to zero. There may have been a period of time where no money was coming into your household. But there were still some costs. Even if you had deferred rent payments, deferred mortgage payments, you still had to buy groceries. Even if you had deferred utility payments, you still needed to eat. So in situations like that, at least for a short time, your profit was probably negative because you were probably losing money. You weren't bringing anything in, but you still had to pay for groceries. Now, in the most favorable circumstances, and what most of us want to get back to, are situations where our profit is positive, where more money is coming into the household than I have to spend on all of my bills. In situations like that, you usually have money left over that you can put into a savings account or put into an investment account, something like that. So be careful. One of the most common errors that I see in this situation is mixing up revenue and profit. Revenue is all the money that comes into the household. Revenue has no idea what your expenses are. Revenue does not care what your expenses are. This is just the amount on your paycheck. Whereas profit is the amount that's left over at the end of the month. We have a company earning money by selling a particular good. Maybe you're earning money by selling cups of coffee or tacos. We have an ice cream truck that comes by our apartment complex pretty regularly. You could be earning money by selling ice cream. Suppose that whatever it is that you're selling, if you sell X units of this good, then the money that is brought into your company is given by the function 10 times X. So just to make this concrete, if you sell, for example, 20 units, then you would be earning $200, say. Now, you've got that revenue function, but your company also has a cost. The cost function, if you sell X units of this good, is given by the square root of 2000x plus 500. So let's have a quick look at a graph of this situation. Here, our company's revenue is given in cyan, and the company's expenses, the cost function, is given in orange. Now, when you have not sold any goods, you usually do still have some expenses for your business. Things like rent for your office, things like payments on your ice cream truck, things like wages for your employees, etc. But generally speaking, as you sell more and more goods, the expenses get larger because every time you sell a good, you either have to manufacture that good or buy it so that you can resell it. So selling goods always has some price associated with it, and the total cost of selling goods rises as the number of goods you sell increases. Likewise, our revenue goes up as we sell more and more goods. Now, as we're selling a relatively small number of goods, maybe we only sell 50 bars of ice cream, 50 cups of coffee. If we sell such a small number of goods, then our expenses are dramatically higher than our revenue is. We paid for our employees, we paid for our truck, we paid our rent, but we really didn't earn that much to compensate for all those initial costs. However, if we take a far zoomed out stance, and we begin to sell more and more and more units of this good, all of a sudden there reaches an important point, a critical point right here, where finally our revenue begins to exceed our expenses. The money that we're bringing into the company outweighs the expenses of manufacturing these goods and the expenses of regular maintenance and upkeep. So it looks like, roughly speaking, if I sell more than maybe 290 of these goods, I will actually be making some money. Now let's go ahead and approach this in a more concrete way. Let's find a function representing the company's profit by selling X units of whatever good we're selling. Now, profit was defined as being equal to revenue minus cost. So all I really need to do is take the revenue function, 10x, and subtract the entire cost function. I can simplify that a little bit if I want to. The profit that results from selling X units of this good is equal to 10 times X minus the square root of 20,000 times X plus, which is now minus 500. Having obtained this formula, what would the company's profit be if they sold 600 units of the good? To answer that question, all that we would have to do is plug 600 into the profit function that we obtained in part A. So according to some side calculations that I have done electronically, the profit at x equals 600 units is approximately $2,035.90. If we wanted the profit at some different production and sales level, if we wanted the profit at 300, still we would just have to plug 300 into this general profit formula. And my side work shows that this gives 50.5. So if I had a choice, if I could somehow control the number of units of the good that I managed to sell, either through advertising or some other means, then I would most certainly prefer to sell 600 units of the good as opposed to 300, because my profit would be significantly larger. Now, technically speaking, when we're dealing with revenue, cost, and profit functions like this, the profit function is not continuous. And the issue is that when you're dealing with X, and X represents units of a good sold, X could only technically be a whole number value. You can't sell, at least I think you cannot sell, 1/3 of an ice cream bar, for example. Now, since X can only take on real number values, then technically the graphs of the revenue, cost function, and profit functions would be absolutely riddled with holes. You would have one point on the graph where X is equal to 1, for example, and then you would have another point on the graph where X is equal to 2, for example, and you would have another point on the graph where X is equal to 3. But since you can't sell half a laptop, since you can't sell 1/4 of a smartphone, you would have these huge gaps in the graph representing the fact that x would not be allowed to take on any fractional values. So really these functions are discontinuous, and they're extremely discontinuous because they're absolutely full of gaps and holes. However, we usually just kind of pretend that these functions are continuous. These gaps look big in this picture, but the truth is that usually when you're doing these calculations, you're working for quite a large business, and x may be on the scale of like 1,000,000. If x is on the scale of millions of units sold, then these gaps between 1 and 2 and 3 look so small that they're practically non-existent. So we usually just pretend that these functions are continuous so that we can use the tools of calculus, which can only be applied to continuous functions. With that pretense, let's go ahead and define something called marginal revenue. Marginal revenue is the derivative of the revenue function. The derivative of revenue, and I'm going to use this language again, with respect to number of units sold. So I'm thinking of revenue as having the input variable represent number of units sold. Marginal revenue is then given by the derivative of the revenue function. Here we've said marginal revenue is the derivative of revenue, and we can just as easily talk about marginal cost. Marginal cost is the derivative of the cost function, where cost has the number of units sold as its input variable. And we can just as well talk about marginal profit. Marginal profit is just the derivative of the profit function, where the input of profit is the number of units sold. So to paraphrase, what is marginal profit and what does it represent? Marginal profit, for example, tells you how your profit changes, how your profit is affected. When you sell more goods. For example, if marginal profit is positive, if P prime of X is positive, then that's a sign that P is increasing. So if your profit is an increasing function, that's a sign that you should sell more goods if you can, because selling more goods would earn you more profit. On the other hand, if your marginal profit is negative, if P prime of X is negative, then that's a sign that your profit function is decreasing. That's a sign that if you sell more goods, then your profit will actually go down. And so this is a sign that you should probably back off and sell fewer goods to increase your profit. Let's try it in the following exercise. So let's go back to the company in exercise 02, where, as we recall, the profit function was given by 10x minus root 20,000x minus 500. Let's find a function representing the object's marginal profit. Marginal profit, which means that I need to find P prime. Now, in order to set myself to be able to use the derivative rules that we have established up to this point, I'm just going to rewrite P of X, the profit function, ever so slightly. I'm going to rewrite this function. 10x is fine. We know how to take the derivative of a number times x. Negative 500 is fine. We know how to take the derivative of 500. That's just a constant. But we have an issue with the square root of 2000 times x. We know how to take the derivative of something like x to the power half, but we don't know how to take the derivative of anything where the base is not x by itself. So what I'm going to do is I'm going to use the properties of exponents to get x as the base all by itself. I'm going to use the fact that if you have 20,000 times x to the power 1/2, that's equivalent to the constant 20,000 to the 1/2 times x to the 1/2. Now the middle term is in the form constant multiple x to a power. And now I can apply power rule and constant multiple rule to figure out the derivative of that term. Okay. So the derivative of 10x is just the constant 10. For the derivative of the second term, the constant multiple rule causes the 20,000 to the 1/2 to stay put. And then let's multiply that by the derivative of x to the 1/2. 1/2 comes down, and then we decrease the power by 1 unit, and it becomes negative 1/2. The derivative of the constant term in the back, negative 500, just completely vanishes. So this function gives the rate of change of profit. This function is telling you whether your profit will go up or go down if you try and sell more goods. So suppose that we are selling 300 goods currently. Let's find the company's marginal profit at x equals 300. And let's answer the question based on that information. Should we try and sell more than 300 goods? Or should we back off and try and sell fewer? What would be best for the company? So let's plug 300 into this formula, and my side work indicates that in this case the marginal profit would be 5.9, which notably is a positive number. Because the marginal profit is positive, that's a sign that the profit is increasing at this point. So if we sell more than 300 goods, if we begin to increase our rate of production, that's going to lead to an increased profit, which in general is better for the company. All other things being equal, I would recommend to this company, if I were a mathematical consultant, that they try and increase their production so that they are selling more than 300 goods. Now, of course, we would all hope that a real company would take into account more than just profit when they're considering how to conduct their business practices. Things like treating their employees well, things like environmental considerations. But as of this moment, profit is still a huge factor when it comes to corporate decision making. So this is how you see that kind of thing show up. Let's consider the following similar example. In this problem, we have a company whose cost function and whose revenue function are both quadratic. And assuming that this cost function and revenue function are reasonable for the company based on the data that they have provided to you, what recommendation would you make them in terms of, in some sense, the optimal amount of goods to manufacture and sell? At what point should the company stop trying to manufacture or sell additional goods? Now, let's try and take this somewhat vague English question and rewrite it in a more concrete mathematical form. At what point, I might say, does the marginal profit switch from positive to negative? When marginal profit is positive, then the profit function is increasing, which is a sign that your profit will go up if you somehow manage to manufacture and sell additional goods. At that point, it's worthwhile for you to at least try to get the number of goods sold up. But once the marginal profit has switched to negative, it is no longer in your company's best interest to try and increase the number of goods that you're selling. If the marginal profit is negative, then that means that the profit function is decreasing, which means that your profit will actually go down if you try and sell and advertise and push more goods. So let's try and figure out at which point marginal profit changes from positive to negative. Now, in order to answer that question, I'm going to apply our good friend intermediate value theorem. Because even though the profit and revenue and cost functions are not technically continuous, they are being treated as functionally, practically, essentially continuous. And since those functions are being treated as continuous, that gives us the ability to use theorems like intermediate value theorem, which apply to continuous functions. Intermediate value theorem says, hey, if you're going to switch from positive to negative, you've got to cross zero somewhere in between. So we can answer this question, at what point does marginal profit become negative? By saying, at what point does marginal profit equal zero? The point where positive becomes negative is attained at a location where the marginal profit is zero exactly. Okay, so now that we have rewritten this question in more concrete mathematical terms, let's now try to actually answer the question mathematically. In order to get the marginal profit, the first thing that I need to get is the regular profit. So the first thing that I need to do is calculate revenue minus cost. So revenue was given by 40x, take away 0.1x squared, and then I'm subtracting the entire cost function, which was 200 plus 10x plus 0.2x squared. So let me clean that up a bit. Our profit function, not marginal just yet, our profit function is given by negative 0.3x squared by combining like terms. Looks like 30x minus 200. Having found the profit, let's go ahead and find the marginal profit, P prime at x. So one by one, applying power rule, the 0.3 will become 0.6 after the 2 comes down. The 30x will become 30, and the minus 200 will vanish. And finally, we're in a position where we have P prime of x, and so we can set P prime of x equal to 0 and solve. So, with a little bit of algebra, we obtain the value x equals 50. So how would I interpret this result? As a consultant, what I would say to this company is that you should increase your production and your advertisement until you're selling approximately x equals 50 goods. If you go anywhere beyond that, then your company is beginning to lose profit. That concludes today's material. We introduced the ideas of revenue, cost, and profit, and talked about the significance of marginal revenue, marginal cost, and marginal profit. We practiced calculating those quantities and using those quantities to answer certain questions that might reasonably ask if you're owning or consulting for a small business.